We're in class, I would have Bell work up on the board and you would, come up, or I would do a problem from yesterday or a problem that's going to help you for this next lesson. So I have for you today a little Bell work problem, and I'm just going to do it. You don't need to copy it down. You can just watch. Okay, that would be fine. So we're doing functions, and yesterday we added, subtracted, multiplied, and divided. And so now we're on 5.5b. And so if I have a problem that's like for f of x, this just means the function is -2, and instead of a number, I put a little box. 2 something squared minus something plus 1. I want you to find, I have to move my face again, sorry. Okay, so I want you to find, how about f of 0? So that 0 just means that you're going to plug in a 0. Everywhere there's an unknown, 0. And I'm not even going to solve it. I'm just going to practice plugging in. I might also say, how about f of -1? Okay. -2 times -1 squared minus -1 plus 1. Awesome. What if, though, I said, how about if you plug in a happy face? So that's going to be -2 happy face squared minus happy face plus 1. So you're just putting in a symbol, okay? Then, what if I put in a variable? How about the alphabet letter A? -2 a squared minus a plus 1. Cool, right? 5. A plus 1. So this is a binomial. So I'm actually going to plug in a binomial everywhere there's a blank. -2 a plus 1 squared minus a plus 1. So I'm putting a binomial in, plus 1. So I can plug in a single number, I can plug in a symbol, I can plug in a binomial, and you're replacing, instead of x or instead of a box, an empty space, you're going to put in a binomial. So that's what we're practicing today. Now on your notes, can you get your notes out? I'll do that now. I am going to give you some basics in the introduction of what we're doing, and then we're going to do some samples together. So okay. Oh, I see. It's that. All right. So here we go. Vocab. Another method to combine functions is called a composition. A composition means you combine things. Given f of x and g of x, so I'm going to give you 2 functions, like maybe it's a binomial, maybe it's a trinomial. The composition function f circle g, that little circle means of, is defined as, so f, it's a little circle, it's like a degree sign, but it goes in the middle. F of g of x is the same as f of g of x. So basically the g is inside the f. The g is going to become a part of the f function. You're going to combine 2 functions together. You're going to put them together. Some big things to remember with this. You will always find g of x first, then plug g of x into f of x. And that's when you're given this one. Okay. So what I'm saying is that you work inside out and you start in the middle. Okay. So I'm putting an F function and a G function together. That's what today is. The composition of a function F with the function G is written as, and we already know this because I put that up above, right? Okay. The domain is going to be the two, what numbers will work when the two are combined. So the domain is the intersection of the inner function and the resulting function. So when the two functions are together, what numbers can I use? That's basically what I mean when I say a result of the inner function and the outer function. Now, I've got numbers 1 and 2, but I need more space. So I'm going to do numbers 1 and 2 on a side piece of paper. And if you want to write small on your paper, or if you want to do it on a separate sheet, that's fine too. But I just want to make sure that I'm going slow enough for everybody so that we're.
I don't really get the domain, like intersection of the inner function and resulting function. So like that's x5.
What we're going to do is it means that when the two functions are put together, what numbers can you use for the values of x? So we'll go through these examples. We only have to find the domain for numbers 1, 2, and 3. And so once I finish number 1, we'll talk about what the domain is. And then for 2 and 3. Your question will get answered. So on number 1, here's what I have. I have let f of x be x plus 2. And then I'm going to have g of x be x squared. Now I have these two functions and I have to basically substitute one in for the other. That's what a composition is. So I'm going to first do number 1, f of g of x. I said up above that you work from the inside out. That means that this g of x needs to be identified. What is it? Well, what's g of x? So g of x is x squared. So now I'm going to write x squared there for g of x. So I'll have f of x squared, right? Because g of x is x squared. So I'm putting g of x. See how g of x is inside f of x? It's in the middle. You start in the middle. So g of x is inside f of x. G of x needs to be put in the f of x. This x squared, which is g of x, right, needs to be put in my f function. So I'm going to take g of x and substitute x squared, because that's what g of x is. G of x is x squared. I'm going to put x squared into f of x. And that means that I'm going to replace the x. G of x is x squared. I'm going to put x squared into, let's write f of x again, x plus 2, right? Isn't that what f of x is? So I'm going to put this x squared in just for the unknown of the function. So I'm going to take out this x right here, and I'm going to put the g in it, which is x squared plus 2. So this x squared was my g of x. I'm going to put my g of x into my f unknown. This variable here is going to become an x squared. The order matters. G of x is in the middle. G of x is what I put into f. My final answer for number 1 is x squared plus 2. And now my domain means when you look at x squared plus 2, what numbers can you plug in? 1, -1, 5, 1/2, -3.8. Can you put in anything? It's a parabola. Yeah. So it's going to be all real numbers. So the domain is, what numbers can I put in to my resulting function? I had g of x. It was x squared. G of x is in the middle. I start from the middle, and I am going to put x squared into the f function. Here it is. X squared goes into my f function, x plus 2. Instead of x, I put whatever g is. G happened to be x squared. Okay. So that's number 1. Let me do number 2. Number 2 is reversed. Number 2 says g of f of x. So real quick, f of x was x plus 2. G of x was x squared. Start from the beginning. So put f of x into the g function. F of x is what? X plus 2. So I have g of f of x. G of, what's f of x? X plus 2. G of f of x. You start in the middle. F of x, it's x plus 2. I'm going to put x plus 2 into my variable for the g function, which is x plus 2 squared. X squared. But instead of x, because it had an inner function, the f of x goes first. It's in the middle. That's x plus 2. X plus 2 goes inside of g, right here. So it's x plus 2 squared. Questions on number 2?
So I'm kind of confused. When you implement the x in there with the squared, like it wouldn't be like it wouldn't be x plus 2 plus x squared. Like why wouldn't it be that?
Because I'm a function is becoming a part of another function. I'm not adding them. If there were a plus sign, I would do what you just said. But I'm embedding one into the other. So you're replacing the x with the other item. The other item happened to be x plus 2. So that's why it's x plus 2 squared.
So if they weren't the same variable, would it just be
Oh, you're always going to have the same variable.
okay?
I'm not going crazy with you and making it extremely difficult. We're just keeping it normal.
Okay.
So the domain for number 2 is also going to be, well, x plus 2 squared, I could simplify it out and FOIL it, x squared plus 4x plus 4. I can write it like that, but still, the domain is going to be all real numbers.
So how does the intersection of the inner function and the resulting function apply? Like, could you clarify?
Because whatever's inside inner function gets worked with, then the resulting function is down here. So it just means these two functions, it's not going to be like, I'm not going to draw it. It's not going to intersect. It just means put the two together and what's the domain? I put one inside the other. I got this. That's the domain. All real numbers. Okay. So
For the composition, so this is like F, like the little open circle. I wasn't really sure how the open circle was.
the open circle is a way to, it's notation. It's a way to write it. So you might see this in a math book and you might see this in a math book, but you just need to be familiar with both. This means a composition, one function combined with another. But maybe a math book in your future will have a little circle. And so you need to be familiar with that too.
Would the circle kind of signify the multiplication? Or?
No, it's not a multiplication problem. It's the two combined. I don't multiply the two functions. Let's do number 3. Okay, look at the middle. The middle is g of x. G of x is where I begin. G of x is 2x minus 5. So I've got g of x, I'm going to rewrite it. I'm going to put f parentheses, what's g of x? Oh, it's 2x minus 5. F of 2x minus 5. You're going to plug in 2x minus 5 into right there, into this x right here. So the g function gets put into the f square root. F of x says the square root of x, but what am I going to put instead of x? What
2x
g was?
minus 5.
Yeah. 2x minus 5, that's x plus 7. So now that I've put them together, it's a composition. I'm going to just do the math. 2x plus 2. Remember, we cannot have a negative. It needs to be a positive number. So it needs to be greater than 0, right? Greater than or equal to 0 in a square root. So it has to be greater than or equal to 0. So my 2x plus 2 is what I'm thinking about. And I'm thinking, what numbers can I use and what numbers can't I use? So the numbers that I can't use are negative numbers. So I want to, the result, 2x plus 2, I want it to be positive. So remember yesterday how in the denominator I said you can't have a 0 in the denominator. So sometimes you set the denominator equal to 0 to find what the domain cannot be. Well, that'd be like whatever over x plus 2. Remember how we said, oh, well, x plus 2 equals 0. X cannot be negative 2. Remember how we did that? And I'd say x could not be negative 2. That's my domain. So with this, I want it to be positive. So I make a little test for my domain. And I'm going to do 2x plus 2 has to be positive, which means greater than or equal to 0. 0 or positive. I'm going to find what numbers I cannot have as my domain. Solve for x, and I'll soon find x has to be greater than or equal to -1. So if x has to be greater than or equal to -1, then it would be written that I have a bracket. My lowest number that I could have is -1, and I can go any number above that. 0, 1, 2, 3, 4, 5, 6, 7, up to infinity, which has a parentheses always. Bracket means -1 is included. So -1, 0, anything bigger than -1. Anything greater than -1. That's going to be my domain. This is a weird one because it was under a square root. Usually they're not like that.
Would there be like a union?
Mm-mm. It doesn't stop and pick up somewhere else, like have a breakage or anything, no. Okay, the backside's a lot easier, you will find. So, okay. I've got an F, a G, and an H. I'm only going to do 2 at a time, so don't worry that it's going to get complicated. It's not. It's not. Here we go. Number 4. Plug G into f of x. Okay. So on number 4, I'm going to rewrite what each thing is, each problem. Like on number 4, I'm going to write f of x equals x cubed plus 8. G of x equals x minus 1. Here we go. F of g of x is this, f of g of x, right? Same meaning. F of g of x. Well, g of x is x minus 1. X minus 1 is here. That's my g of x. I'm going to plug x minus 1 into my f function. That means that I'm going to put this x minus 1 in for the x unknown right there. So it's something cubed plus 8, right? X cubed plus 8. But I'm going to put x minus 1 cubed plus 8. You actually have to do it out. You have to do all the numbers. So it's like written 3 times, you know, x minus 1, x minus 1. You multiply a lot, a lot, a lot. Let me just give you the answer, okay? Final answer, x cubed minus 3x squared plus 3x plus 7. And remember, this is on video too, so you'll be able to go back. So if there's something that needs to be worked out, like multiplied out, you multiply it out. Okay, I'm gonna go to number 5. We're not doing number 6. So if you're working ahead, don't do number 6. Number 5. This is the same as h of g of x, right?
for the previous 4, do you add the 8 to the
It was, the 8 got added to a -1.
Oh, okay. Yeah.
So start inside. Stay with me. The g of x is, oh, I gotta write it. So I wrote down both again, because I, draw my green circles and everything. G of x is in the middle. G of x gets put in side my h function. I'm going to put x minus 1 instead of the x over there for the h function. H, oh wait, I'm sorry, 5x minus 3. Ready? 5x minus 3. What do I put instead? The g of x. So now I've replaced it, I've combined them, and I just simplify. This has a parenthesis, so I'm going to have to do distributive property, okay? 5x minus 5 minus 3. 5x minus 8. Okay? And you're done. Okay, number 7. G of f of x. G of f of x. Everybody with me still? You guys, any questions? Okay. G of x is x minus 1. F of x is x cubed plus 8. All right. So start in the middle. G of f of x, right? Start with f of x in the middle. F of x is x cubed plus 8. G of x cubed plus 8. I'm going to put x cubed plus 8 inside the g. I'm going to replace it. So that is x minus 1. X minus 1. What is it? X cubed plus 8.
So I basically substitute the x, like the g of x, with the x cubed plus 8.
Yep. Good. And then you just do the math. X cubed plus 8 minus 1, okay? X cubed plus 7. Just simplifying it. So 4, 5, and 6, I didn't have to find the domain. I just practiced substituting them. 8 and 9 give me a value to plug in. So let me do a little instructions. Number 1, plug 2 into h. So this is g of h of 2, which is, plug 2 into h. H is 5x minus 3. So I'm putting a 2 there instead of the x. H of 2 is 5 times 2 minus 3. H of 2 equals 10 minus 3, 7.
Wait, I'm confused. So why did you put plug in 2 into H?
Because instead of an unknown x, they gave me a value. And so h of 2, what's that? I got to find h of 2. So go to your h, 5x minus 3, plug 2 in. Because now the middle, you always start in the middle, right? H of 2. So that's why I did the 2 first. And now my g of 7, right? Isn't 7 the same as h of 2? G is x minus 1. 7 minus 1. So x minus 1 is my g function. I plug 7 in, 7 minus 1. So instead of just an x, they actually give you a value. Step 2, plug 7 into your g function. So I'm plugging numbers in. 7 minus 1 is 6, which means g of h of 2 equals 6.
So like G of H of X. So you substitute the 2 in X, kind of like.
Yes, yes.
Okay.
Let's try another one. Let's try number 9. It says h of f of negative 6. Step 1, plug negative 6 into my f. F of x was x cubed plus 8. H of x was 5x minus 3. It's easier to write them than to have to keep looking up the top of the paper. So I'm going to plug negative 6 into f. F of negative 6. Well, f is x cubed plus 8. Negative 6 cubed plus 8, right? Negative 6 cubed is negative 216. Negative 6 times negative 6 times negative 6 plus 8. So f of negative 6 equals negative 208. Then step 2 is going to be plug negative 208 into my h function. So my h function is 5x minus 3. Well, instead of x, I'm going to put negative 208. It also would be like, you could also put h of negative 208 equals. Uh, 5 times negative 208, and then you take away 3 is, you guys can use a calculator in this class. H of f of negative 6 equals negative 1043.